every now and then we hear that somebody discovered Atlantis, and then it turns out that it's not quite true. So it goes back to some Greek legends, and Plato talks about it. And it's the Sea of Atlas, the Atlantic Sea, where Atlantis is supposed to be located. Some people say it could be in the Mediterranean, and there was a big eruption of a volcano at Santorini, and it surely inspired Plato. But it's very clear in the writing, the lost continent is out in the Atlantic Sea. It's beyond the Pillars of Hercules, which is Gibraltar, and therefore we have to look for this out there, far out there. So it's called Atlantis because of the location beyond the Pillars of Hercules, where Atlas, the giant, was actually holding the sky. And then there's a little story about Hercules taking over, but then he wants to get out of the job, and he tricks the giant to come back, and then he runs away. So, and if you were to sail out of Gibraltar, then you come to this place, the Azores. I just talked about it. And very often in old maps, we find Atlantis to be located where we find the Azores. The map in the lower left, it's an old map, and it's a bit confused actually, because the north arrow points downwards. So you have Africa above Europe there, and America on the other side. So it's, in our current view, the wrong way around. But what is striking is there's a volcano in the middle. So, and if you read the accounts, then the idea is that there was a large landscape with big mountains, and it drowned, and there's volcanoes or tips of mountains just sticking out today. That's where you would find Atlantis. I don't know how much of this is just imagination, but you can actually look at several of these artists' impression built or based on descriptions from the old days. And again, in the top right, you see this big volcano there. I actually think that this volcano in the Azores gave rise to this idea. It's Pico volcano, pointedly called Pico, and it's a beautiful little peak that stands out there. And I think this is a place where a lot of sailors would have come by, and this may have given rise to this idea. If you think about some of the discussions that you have, or some of the descriptions in various pieces of literature, there must have been a very well-developed, far advanced society and civilization that sank into the ocean. And according to some descriptions, they had a channel system, and they had rings of different population centers. But, well, every now and then, as I said, you get these news like this one here, Atlantis found. And in this case, a rock formation off Britain was considered as a potential place, the Rockall Trough, as geologists know it. And I must disappoint the readers of the Express. It's not Atlantis. It's actually old rocks to do with Iceland. And there we have the grey rocks that come from the initial eruptions of the Iceland plume when the Atlantic started to spread in this part of the world. It's well known for geologists. We have drill samples from there. It's not Atlantis, I assure you. But there is one real good candidate for Atlantis, and it makes me shiver each time I'm thinking about it. It's called Doggerland. It's a really strange area which goes, which is between present-day UK, Britain, and Denmark and the Netherlands. There is a large area that has been above sea level back in the days when most of the water was caught up in glaciers. During the last glaciation, this was land that we could walk on. And we know that because fishermen are bringing up weird things from there. There's a mammoth skeleton that was brought up, and I'm showing this in the lower right. There's actual buildings down there. And, or at least you can see some constructions with sonar. And this is an area that really drowned. It drowned some 6,000–7,000 years ago, and the word of this would have reached Greece. But by the time it gets there, it wouldn't be a simple story. It would be a convoluted story about some major civilization that sank into the ocean. And I think this is the real Atlantis, if you ask me. Certainly it's my best bet right now. So here's a few more impressions of that. And once the glaciers melted, then of course the water was creeping in, and Here in the top left, you can just about see this. The sea level rise lasted until about 5,000 before our time, and then it started to peter out. And of course, the area between the UK and Denmark and the Netherlands was drowning gradually. At the same time, we have the ice retreating, and there are several red lines here in the right-hand map. This is from the northern Germany area and Poland, and that's where the ice receded at the same time as the water was rising and drowning Doggerland. There's still one area there, the Dogger Bank. This is going old from left to young to the right. So here we have the ice sheet indicated with that faint pastel color in the top, and then the ice retreats and the water rises as a consequence, and the area drowns. And there's still a shallow bit, we call it Dogger Bank, but it's below the ocean, but you have to be a little careful when sailing there. So now, having talked about Atlantis, I'd like to close with a very brief consideration about resources. And Atlantis was supposed to be rich, and the Atlantic is teeming with resources, but not quite in the way Plato envisaged it. It's a little bit more complicated. So these days we are desperate for a certain amount of metals, for certain types of metals, and this includes what people call critical metals, but it includes also some very standard metals. One of the key metals here is copper. We have an issue with copper. We are likely going to run out if we electrify the traffic. And here is a little sketch on the right-hand side. This gives you the amount of copper that is needed for a conventional car. And this is an American source, hence it's in pounds. So a conventional car requires up to about 50 pounds of copper. If you have a hybrid vehicle, 85 pounds, and then the bigger the vehicles go, well, 196 for a hybrid electrical bus. But if you go towards a fully battery driven or battery supplied electrical bus type vehicle, you need over 800 pounds of copper. And some people want to electrify air traffic as well. So the amount of copper we need will be mind-blowing. And where do we get that from? Well, I think we pushed the limits on the continents pretty hard. There is a few more things we can do in places like South America, but ultimately we're likely going to struggle to produce enough copper with traditional mining. This is why a lot of people are thinking about mining in extreme environments. The ocean floor is one of those frontiers, and space is another frontier. And I talked about the black smokers before, and I said they are black because you have tiny little metal precipitation, tiny little grains of metal that precipitate there, and that contains copper, but also zinc and iron and lead and other metals. So they make these mounds, and these mounds are on the ocean floor, and if you get down to the ocean floor, the idea is you could scoop these mounds up, and they would contain a lot of metals. Naturally, you would be scooping up all the other things there as well. So any form of life, any kind of vent community would be part of your scoop, I'm afraid. So this is a bit of an issue, but let's look a little bit further into this. So here's the idea. We have cold ocean water seeping in. It's getting close to a heat source, a magma reservoir. On the right-hand side, I'm showing this. It's gonna get heated up. The hot water is percolating through the rocks. When it does that, it leaches out metals. And then when the hot fluids reaching the ocean floor in the cold environment of the seawater, all these metals start to precipitate. And cold water has, well, a very normal pH, pH 8, and it's very metal deficient, obviously, but these hydrothermal fluids, they're very acidic, and they come with 100 parts per million iron, 33 parts per million manganese, and 2 parts per million copper. And that's not a bad grade for mining, because copper is usually mined as a disseminated ore, where we mine large quantity of rock to get a little bit of copper. So, and we often make these crusts there, around there. This dark crust in this particular rock sample is rich in cobalt and manganese. and we need cobalt for batteries. So this is becoming increasingly attractive for certain industries. To give you a flavor here, this is a cobalt projection, and here we are producing all the cobalt we can produce right now. This is the black line in the right-hand graph, and most likely we cannot push it with our conventional mining. That's the red dotted line, but the demand will be a lot higher. And by 2030, in just a few years, the projected demand will be almost double of what we are producing. So this is why the Dutch government has only last year given a large research grant for exploring submarine mining. And how does this look? Well, we have vast fields of these crusts, and sometimes these crusts make nodule if they come around a little rock fragment or so, and there is literally fields of these nodules at the ocean floor. And, well, some people think you could just develop a giant hoover and hoover them up. This is an idea that comes from Namibia, because there's a bunch of, well, wild young sailors that have come up with the idea of hoovering muds that come from areas where diamonds are contained, and they're just going outside the 12-mile zone, and they're looking for a shallow bit, and they're hoovering up things, and quite successfully. De Beers can't do anything. And so they made a fortune with this, and of course, people are now thinking, maybe we can do this also for the deep ocean. I'm showing a few cuts through some of them, so often there's a rock fragment inside, and these crusts, they form around. Now, these are artists' impressions. This is not reality, let me stress. This is just wild ideas for now. But people are going quite wild on the wild ideas. And here's various ideas that are currently being explored. There is machinery that would be traveling on the ocean floor, likely not with a miner in situ or with a miner in place, but all remote controlled. And that could allow us to graze off these resources from the ocean floor. So could we do deep sea mining for manganese and cobalt? I guess it's possible, and if it's possible, it'll likely gonna come in the future. There is problems, I'm not gonna hide that. There is different issues. There's of course all these ecosystems down there, and it's not huge ecosystems, it's not the macrofauna, it's the tiny little animals we have to be concerned about. And only recently people have pointed out, it seems that these manganese nodules, they're also releasing oxygen when they form, and this could be one of the main contributors for making oxygen. People call it dark oxygen, because it's not an organic way of making oxygen. It's not via photosynthesis, it's an inorganic way. We don't quite know how big and important this phenomenon is, but mining the source for oxygen might not be the best idea. And this is a little cartoon from Greenpeace, and here I thought it was quite fitting where these two people in the submersible are talking. What are we using all these minerals for? Well, to make clean technology. And of course, we harm the nature in a different way. So what I usually talk with my students about is wicked problems. It's one of those issues. You want to fix one problem, but you're creating another problem. The big challenge for us is to find the balance here between these processes. We need to maybe think about some mining, but we also need to think about protecting things and preserving things. One discussion is if we were to mine in small strips, then there could be recolonization of the mined areas from those areas that have not been excavated. But we are very, very early in the process. Nobody is actually doing this right now. But I'd like to close with Jules Verne again, one of my all-time heroes. And Jules Verne was quite perceptive. He had seen all of these things we're discussing before. He had seen submarine volcanoes. All his wealth in Captain Nemo's wealth in 30,000 Leagues Under the Ocean all came from resources in the Atlantic of ore deposits under the water. So all of this is true. And he talked about giant life forms down there with whom humans will need to struggle. I think he got the last bit a tiny little wrong. It's not the giant beasts we have to worry about, actually. It's the tiny microbiota we have to really be concerned with. Thank you very much for your time, and I hope you found this useful.